2.4 Few definitions relating to vector. In this lesson, we will learn about different types of vectors. We will learn about free vector, localized vector, like vector, unlike vector, equal vector, opposite or negative vector, collinear vector, coplanar vector, proper vector, null vector, unit vector, position vector, displacement vector, reciprocal vector. All these vectors are mentioned in our curriculum book. So number 1, free vector. When the initial point of a vector is not fixed, that vector is called free vector. That is, if we can choose the initial point of a vector as our wish, then we call it a free vector. For example, you have walked 5 meters towards east, and your brother, who is 10 meters behind from you, has also traveled 5 meters towards east. Though the initial point is not fixed here, magnitude of both the vectors are same, so they are called free vectors. So the conditions of a free vector are: number 1, magnitude must be equal. Number 2, initial point is not fixed. Now we come to our second type of vector, which is localized vector. The localized vector is exactly the opposite of the free vector. For example, you need to travel to Chittagong. So to travel to Chittagong, you have to get on train from Kamalapur railway station. So Kamalapur railway station is the initial point of your vector. So in this case, the initial point is fixed. Again, if you know about the position vector, you know that position vector is counted in accordance with the origin. So position vector is also a localized vector since it is counted on the basis of the origin. So the condition of localized vector is initial point must be fixed. Now let us come to our third topic, which is like vectors. If two or more than two vectors of same kind act along the same direction, are called like or parallel vectors. Okay, what do we mean by the same kind? Same kind means either both the vectors should be displacement or force or velocity or etc. etc. So if you're traveling towards north 5 meter and your brother is traveling towards north and his displacement is 10 meters. See, both the vectors are of same kind, i.e. displacement, and both the vectors are parallel to each other, so they are called like or parallel vectors. In this case, the magnitude might be equal or might not be equal. That is not the factor. The factor is they need to be of same kind of vector and they need to be parallel. Then these two vectors can be called like or parallel vectors. The condition of like or parallel vectors are: should be parallel, magnitude might be or might not be equal, they should be, number 3, they should be of the same kind. Now coming to our fourth vector, which is unlike vector. It is exactly as opposite as like vector. So in this case, we can say if two vectors of same kind act along opposite direction, then they are called unlike vectors. Suppose you are traveling towards east and your displacement is 5 meter, and your friend is traveling towards west and his displacement is 5 meter. Both the vectors should be parallel and they should be of the same kind, but their direction should be opposite. So in this case, the conditions will be: number 1, they should be of the same kind. Number 2, they should be parallel to each other. Number 3, direction should be opposite. Number 4, magnitude can or cannot be equal. So coming to our fifth type of vector, which is equal vector, we get when the magnitude of two vectors are equal and they are of same kinds, and if they act in the same direction, that is parallel to each other, then they are called equal vectors. Suppose you're traveling from your home to a shopping center, and your sister is also traveling to a shopping center from your home. So let's see here, both of your displacements are same. In this case, both of your vectors are of same kind and both the vectors are parallel, and both of the vectors are acting towards a definite direction, and which is shopping center. And you can see here that the magnitude, the total displacement of you and your sister is also equal. If your displacement is 100 meter, then your sister's displacement would also be 100 meter, because both of your initial point and your terminal point is equal. Now, what if the initial point is not fixed? What if you travel 5 meters towards east and your sister, starting from 2 meters behind you, travel 5 meters towards east? In this case also, both the vectors can be called equal vector. It doesn't matter what is the initial point. What does matter is both the vectors should be of same kind, they should be parallel, their direction should be towards the same direction, and the magnitude of the vectors should be equal. In this case, we can say that A vector is equal to B vector. Now coming to our sixth type of vector, which is opposite vector. It is exactly the opposite of equal vector. So what is it? In this case, magnitude should be equal. Number 2, initial point might not be fixed. Number 3, direction should be opposite. Number 4, same kind of vectors. Number 5, parallel to each other. Suppose you are facing your friend. You are here at A point and your friend here, he is at B point. You have traveled 5 meters towards east and he has traveled 5 meters towards west. Both of these displacements are parallel to each other and both of the vectors are of same kind. Let the magnitude of the vectors, i.e. the magnitude of the displacements, is 5 meter. In this case, these two vectors will be called as opposite vectors. Coming to our seventh type of vector, which is collinear vector. When two vectors act along a straight line or parallel to each other, then they are called collinear vectors. In this case, suppose A is starting from point here, A, and B is starting from here, and C is starting from exactly behind B, from here, C. In this case, C and B are following the same straight line, while A is parallel to B or C vector. In this case, these three vectors, A vector, B vector, and C vector, are all called collinear vector to each other. Now coming to our eighth type of vector, which is coplanar vector. When two or more vectors lie in the same plane, then they are called coplanar vectors. Suppose my screen or your device's screen, both of the screen are two-dimensional. And we know two dimensions form a plane. That is xy or xz or yz. When two or more vectors lie in the same plane, that is A vector and B vector, they lie on the same plane, so they are called coplanar. And in the case of xz axis, if two vectors are P and Q, these two vectors lie in the same plane, so they are also called coplanar. And in case of yz axis, if there are two vectors, and they are also called coplanar. But if there are three axes, then what will happen? In case of A vector is situated on the axis of between y and z. B vector is situated on the axis between y and x. And here C vector is situated in between three of the axes. So they can't be called coplanar vectors since they do not have a common plane. So if your arrangement is three-dimensional, in that case you will face some difficulties finding coplanar vectors. But if your arrangement is of two-dimensional, then all the vectors that you write on a two-dimensional structure, all of them will be called coplanar. Now coming to our ninth type of vector, which is proper vector. The vectors whose magnitude is not equal to 0, those vectors are called proper vector, while the 10th vector, which is null vector, their magnitude is equal to 0. Okay, in this case, what is the direction of this null vector? Suppose you are going to your school. You didn't yet start your journey, but you are facing your school. You are facing your school, but you didn't even start your journey. So your magnitude is 0. But since you are facing your school, so you have a direction which is towards what? Towards your school. So null vector, though it does not have any magnitude, it should have direction. Without direction, we can call a quantity vector. Now coming to our 11th type of vector, which is unit vector, we get the vector whose magnitude is 1 is called unit vector. In this case, if you're traveling to your school, if you have proceeded only 1 meter, then this vector is called unit vector. Again, if you divide a vector with its magnitude, you will get the unit vector. Suppose your vector is A and the magnitude of A vector is A modulus, then we get the unit vector is A divided by A modulus, then we get A cap. This is your unit vector. Since unit vector has an immense importance in vector algebra, a different sign, that is a cap. Cap is used over our vector instead of arrow. Now coming to our 12th type of vector, which is position vector, we get the vector which determines the position of a point with respect to origin of the reference frame. Suppose our reference frame is this x and y axis, and here is a point which is A, and if the position of the A point is determined with respect to the origin, then we call it position vector. Again, if B is a point and if the position of B vector, B point is determined with the help of origin, then this vector will be called B vector. So my question is, if the position vector of A is OA and the position vector of B is OB, then what will be the value of AB vector? If OA vector denotes A vector and OB vector denotes small letter b vector, then by applying vector law of triangle, we get OA plus AB equals to OB. Therefore, AB vector is equals to OB minus OA equals to OB was denoted by B minus A. In this way, we can calculate the position vector of a point. Now coming to our 13th type of vector, which is displacement vector. The change in position of a vector is called displacement vector. Suppose we draw a reference frame, x-axis, y-axis, and here is a vector. You have first traveled to position A, and then from position A to you travel to position B. So the position vector of B would be OB. So what would be your displacement vector? Your displacement vector will be your final position subtract your initial position. That is, displacement vector is denoted by del R equals to your final position is RF minus your initial position is RI. This is called displacement vector. Our 14th type of vector is reciprocal vector. If the magnitudes of two vectors are reciprocal to each other, then those vectors will be called reciprocal vectors. Suppose a vector is 10i and another vector is 1 by 10i. I denotes the direction towards x-axis. See the magnitude part. A's magnitude is 10, B's magnitude is 1 by 10. So these vectors are called reciprocal vectors because 10 and 1 by 10 are reciprocal to each other. So this is the end of this topic.